What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at solving trig equations using Pythagorean identities. And we're going to look at the mama bear Pythagorean identity. Sine squared plus cosine squared equals 1. That's right. So let's go ahead and take a look at this. Now, what we're going to start out with, we're just going to simply go through this process here and divide each term by sine squared for part A. Because what we're going to do is kind of prove where the other two identities come from. So sine squared plus cosine squared equals 1. And our angle here is theta. So if we were to divide each one of these terms, so divide that by sine squared, divide the cosine by sine squared, and divide 1 by sine squared. That's going to result in another equation. And sine squared divided by sine squared, of course, that's just 1. Cosine squared divided by sine squared, that is going to give us cotangent squared of theta. And then 1 over sine squared. So remember, the reciprocal function of sine has a reciprocal function of cosecant. So that's going to be cosecant squared theta. So if we were to take each one of these terms, sine squared plus cosine squared equals 1, and divide it by each term by sine squared, then that would give us the resulting equation, 1 plus cotangent squared equals cosecant squared. Now, similarly, we're going to do the same thing over here for part B, only this time we're going to divide by cosine squared. So if we divide each term by cosine squared, that is going to result in another Pythagorean identity. Now, when you do that, do pay attention to the thetas. Don't forget them. Little details here and there. Now, sine squared over cosine squared, that's just tangent squared. And then cosine squared divided by itself is 1. And 1 over cosine, again, what's our trig function? That's the reciprocal of cosine, and that would be secant. So 1 over cosine squared is the same thing as secant squared. So when we do that, when we divide each term by cosine squared, we get this other Pythagorean identity right here. And this one is going to be called the baby. I'm going to call that one the baby one. That's the baby one. And then this guy over here is going to be papa. That's going to be the papa. So we got mama theorem, baby theorem, papa theorem, and of course mama is this guy right here, that original one, sine squared plus cosine squared equals 1. That's mama theorem. So these are going to be the big three. All right, now, and you'll need to memorize those, but in this section what we're going to do is not actually work with those in particular. We're going to be making substitutions. We're going to be making substitutions. And so with each one of these, we're going to do only one of them here in this video. We're going to work with just the very first one. And if we were to solve sine squared plus cosine squared equals 1 for one of those trig functions, we'd get a different version of that. And that version is what we're going to use when we solve trig equations using Pythagorean identities. So if we were to solve for sine squared, that means I would have sine squared theta equals 1 minus cosine squared theta. Because what we really just did was we took cosine squared and we're like, move it to the other side. And when we do that, we're left with just sine squared on the left and then 1 minus cos squared on the right. However, if instead of solving for sine squared, say we wanted to solve for cosine squared, that means sine squared has got to go to the other side. So then this other version would be cosine squared of theta equals 1 minus sine squared theta. So generally speaking, when we do our substitutions, we're going to use one of those alternate versions to help us solve our trig equations. All right. So let's take a look here. We're going to do two examples together. And again, we're going to take a look at these going from 0 to 360 and 0 to 2 pi. So we're going to use both of them. Now, when we look at this, first thing I want you to identify is the type of terms that we have. And just kind of a review. If you have something to the second power, that's going to be called a quadratic term. So that's a quadratic term, sine squared, and also cosine squared is going to be another quadratic term. So we've got two quadratic terms, and then I've got one linear term. Now, the way you analyze this, there's kind of two different ways you could think about it. One of them, you could play the game of like, one of these things is not like the other. One of these things just doesn't belong. And so if you look at the three trig functions, you have sine squared, sine, and cosine squared. The one that doesn't belong would be cosine squared. So that's the one that needs to get substituted out. And how does it get substituted out? With one of those alternate forms of the mama bear, Pythagorean identity. So what we're going to do, cosine squared, this is going to go in its place, 1 minus sine squared. Okay, so when we do that, we're just going to simply make that substitution. And it's really just straightforward. So negative sine squared theta equals sine theta. And this is where you have to be careful. Watch the minus sign, and then it's 1 minus sine squared theta. From here, be uber careful when you distribute that negative sign, because a lot of people might make a mistake right there. So you'd have negative sine squared theta equals sine theta minus 1 plus sine squared theta. All right, so now we've got all three terms that have a trig function with it. They're all the same trig function. They're all sines, whether it's a sine or a sine squared. Now, what we're going to do after this, we're going to take this sine squared on the left side, and we're going to move that over to the right, and we're going to also rewrite it in standard form. So standard form means from the highest degree all the way down to the lowest degree, and then the constant. So in doing so, we'll have 0. Now, if I add sine squared to the other side, that's going to give us 2 sine squared theta. And then I'm going to move the sine theta next, so that'll be plus sine theta. And then I have my minus 1. So that is going to be my trig equation that I would have to work with. From here, all we need to do is solve by factoring. So when you factor this, 2 sine squared theta is only going to be able to factor into 2 sine theta and sine theta. Much the same way, if you had 2x squared, that can only be broken down into 2x and x if you have different parentheses. All right. Now, along those same lines, then we've got to take a look at negative 1. So the only way to break down negative 1 is going to be 1 and 1. Now, which one of those gets the negative? That's where we're going to have to always double check, make sure our signs are okay. But since my middle term, my linear term, is plus sine theta, the plus sign would go right there, and the minus sign would go right there. Now, you can always double check this by taking what you have in factored form right there, and you could FOIL that back out, and you would end up with what you got before. So if I were to multiply that together, 2 sine theta minus 1 times sine theta plus 1. If you were to FOIL that out, 2 sine times sine is 2 sine squared theta. And then 2 sine times 1 gives me plus 2 sine theta. And then negative 1 times sine gives me negative 1 sine theta, but we don't write the negative 1 with it. And then negative 1 times 1 gives me negative 1. Cleaning up these middle terms, you'll see we get the expression that matches what I had above it. All right, so that's what you always want. You always want it to be matchy-matchy with what we had to begin with. So you can always double check using that technique. Now from here, you guys have worked with these before, so I know you'll be really solid with it. So make sure you write this step first. 2 sine theta minus 1 equals 0. And then that'll give you sine theta equals, move the 1 over, and then divide by 2, you'll get 1/2. On the other side, we get sine theta plus 1 equals 0. So that means we will end up with sine theta equals negative 1. From here, we simply look on the unit circle. And when we do that, we've got to make sure we put our answers in both degrees and radians. So on the left side, we'll have theta is going to be equal, sine's my y coordinate, so where the y is 1/2, that's going to be at 30 degrees and 150 degrees on the unit circle. And then those values in radians are going to be pi over 6 and 5 pi's over 6. And then sine being negative 1, that occurs in one spot and only one spot, and that's at 270 degrees, or 3 pi's over 2. And that's it. So there's a lot that's involved in this, so a lot of steps in there. So take your time, be really super duper careful, and make sure that you're good to go. Now let's take a look at example number 2 here as we kind of roll through this one. So again, we're going to analyze our terms here. We've got cosine squared, right? So that's my quadratic term. This is also a quadratic term. The plus 2, that's just a constant, and then my other trig function, that's a linear term. So when I look at those three pieces, the quadratic terms and the linear terms, which one doesn't belong? Which one of those is not like the other? And that's my sine squared one. So sine squared, that's going to be swapped out with, and again, so sine squared, that's going to be 1 minus cosine squared. So that's what's going to go in place of 1 minus sine squared. So when we rewrite this, right, we'll just have cosine squared theta minus, and again, be careful because that negative sign, 1 minus cosine squared theta. So we're just doing a substitution, that's it. And then plus 2 equals our 3 cosine of theta. From here, we'll distribute that negative, so that'll give us cosine squared theta minus 1 plus another cosine squared theta, and then plus 2 equals 3 cosine theta. Now, we're going to move that 3 cosine squared theta, and then we're also going to combine our 2 cosine squared. So we're going to do a couple steps here at once. When I combine the 2 cosine squareds, or the 2 cosine squared terms, you'll get 2 cosine squared theta. When I take that 3 cosine theta on the right and move it over to the left, that'll give me minus 3 cosine theta. And then when I have these two guys right here, so I'm going to circle them. So when you have a minus 1 and a plus 2, that is going to end up giving us a plus 1 equals 0. And again, from here, take our time. We'll make sure I'll factor. And this is going to factor into, so 2 cos squared can only be 2 cosine theta and cosine theta. Now, plus 1, there's only one way to get plus 1. I can either have 1 times 1 or negative 1 times negative 1. Now, if you remember from your algebra days, if this middle term is negative and your last term is positive, if your linear term is negative and your constant term is positive, both of these guys would be negative. All right, so then you take each factor, set it equal to 0, cosine theta minus 1 equals 0, and then cosine theta equals 1/2. And then on the other side, we get cosine minus 1 equals 0. Don't forget the theta. And then you'll get cosine theta equals positive 1. So again, we'll look on the unit circle and we see where those values are, and we'll write them in both degrees and radians. So cosine is going to be 1/2 at 60 degrees. And because cosines are x-coordinates, so you just want to think about that on the unit circle. Since that's positive, you're going to go here and here. So that's where 60 is. And then 60 degrees below the x-axis would be 300 degrees, period. So 60 and 300, which also are the same thing as pi over 3 and 5 pi's over 3. Now where cosine is 1, all right, that's my x-axis, so 1 would be right there. So be really careful here. Theta is just going to be 0. Theta is just going to be 0. And then that's theta in degrees, and theta in radians would just be the same thing, 0. And you don't have to put a pi next to it, and that's it. So take your time. The hardest thing for a lot of people with these is going to be the factoring, because this really emphasizes your factoring skills from Algebra 1 days, but we're going to really kick it up a notch with factoring and doing a little substituting on top of that. All right, so that's it for this video. Thank you guys for watching. Good luck on the homework, and I'll catch you later for the other ones. Peace out.